Hi guys, so I thought about making like a short recap video of my previous LN2 session. So overall it didn't go so well in all aspects. I lost a lot of LN2 with just due to messing around and everything. So first I tried both of the Kaby Lake X7740X CPUs on LN2 on the X299 OC Formula. So I used either of the, one of the two chips in the Kaby Lake X deleting video, because that was the one that I bought from eBay just for fun and out of interest. And one CPU was from a local user here in Finland who found a 5.5 GHz Cinebench one on water, and we talked a little bit, and he wanted to see that how well it could do on LN2, as he doesn't do extreme overclocking like I did. But so that loaned one was the first one I tried on LN2, and it maxed at around 6.9 GHz for Cinebench R15, but it was really like barely at 6.9. So at 6.9, when I would start Cinebench, it would go through like 60 to 80%, and then it would fail. So it's pretty much like 6.9 max. So it is not good enough for me, as the original engineering sample that I still have, that does like 6.95 to 7 for things like that. So it's a little bit better than the retail one I now tested. And then when I moved on to the L653B batch CPU that I got from eBay, that one just doesn't go to full pot at all. So it stops right before -150 degrees Celsius, no matter what settings I use in the BIOS. So I'm not fully sure what is the issue with that CPU, but I think for now, so the only way to get past that temperature would be to add the DMI voltage with the CPU. So the DMI voltage is the funny thing about the Kaby Lake X CPUs when it comes to extreme overclocking on LN2, because it doesn't exist out of the box or by default on the Kaby Lake X generation, the same way it does on the mainstream socket. And there are like a significant amount of Kaby Lake X CPUs that need that voltage to get to full pot. So that's the only that's the last solution I can try to get the this specific 7740X sample to full pot. So the way to do that, well, I could use Rampage VI Apex, the board that became famous for its Kaby Lake X extreme overclocking, because it has that extra pin you can solder from the backside of the motherboard, which touches one of the SMD caps on the bottom side of the CPU. On X299 OC Formula, as well as on the dark, there is a hole in the middle of the CPU socket, so you could just solder a simple like small wire on the same spot as the Rampage VI Apex pin would touch, and then I could just manually apply that voltage from some of the other voltages on the motherboard, exactly the same way as I do on the 775 Rampage Extreme, as both of my Rampage Extreme boards are PLL modded. So I just set the CPU PLL manually from another voltage source on the motherboard. So I could just solder the back of the CPU to, let's say, like CPU PLL. So when I set CPU PLL in the BIOS, it sets that voltage both for the CPU PLL as well as for the DMI. So that could work. So I wouldn't have to get my hands on a Rampage VI Apex. So I could do that much cheaper that way. So we will have to see about that. I need to find out how to do that. So that's the last option. However, the way it cold bugged was not so that I got black screen or similar, as usually DMI issue is that you lose screen, so that the screen just goes black. It was just normal like cold bug hang, but that's pretty much the last solution I can try to get the CPU to full pot, as I tested all the different voltage combinations possible but otherwise the CPU seemed quite good. So it was doing like 6.6 something at -140 with relatively low voltage, like 1.65, so that is very, very good. So if I got it to full pot, it should do at least 6.9 for multi-core tests like Cinebench and so on. So I need to see about that. So the Kaby Lake X part didn't go that well. Then I tested the 7350K on the Maximus 9 Apex. Thanks again to Jokert for lending me the board once again, as I don't have a motherboard for Skylake or Kaby Lake at the moment. That we already covered, so it did 6.65 max for Cinebench, etc. with very good cache of 6.45. As even that wasn't good enough for me, so then I just moved on and I started testing the 9900K arrow stepping again on 3D. So I moved on to testing the GTX 680 Lightning that I got from eBay some time ago, but it didn't go well at all. So I did all the necessary changes to the 680 Lightning. So I shorted all of the shunt resistors that exist on the graphics card's PCB. So there are 2 for the 8-pin connectors and 1 is for the PCI Express slot. So 2 of them are here and 1 exists just underneath this cooling heatsink. So I did those. Then I also cut the original heatsink assembly in 2 parts. So the original heatsink assembly cools both the VRM on the front side of the card as well as all the memory chips around the GPU itself. But the way for LN2 is that it kind of blocks the GPU pot, so we still want to cool the MOSFETs as they get really, really hot on LN2, but we don't need any heatsink on the memory as this area freezes up anyways. So I just used a normal like metal saw to just cut the heatsink in 2 pieces. I did this on the 7970 Lightning many times already, so this works just fine, as we have to remember that this card doesn't have like any warranty anymore, so we can do radical changes like this. But the so the Lightning wasn't good at all. So it cold bugged already at around like -80 degrees, so that is not a good temperature at all. So -80, not 180, just -80. And the maximum GPU clock ended up being like around like 1750 or 1800. So that is far behind what, for example, Kingpin did back in 2012 with the 680 Classified. He ran 3D Mark 11 like well over 2 GHz on the core. I think almost 2.1. So that's really far behind. And also for the 680 Lightning, you have to use the afterburner extreme, some kind of afterburner extreme to get enough range on the voltages and clocks. And the funny thing is, so when I used my normal APX version, which I normally use for 7970 Lightning and so on, it didn't have enough clock range on the GPU clock at all. So I was like hitting the max limit on that. But anyways, it wouldn't have gone any further than that, as it was already crashing at around that clock speed. So 1750 to 1800. Then I just stopped it already. But I used a lot of time and LN2 on troubleshooting the 9900K arrow stepping, and now I can fully confirm that the arrow stepping 9900K has degraded. So something happened back in September when I benched the 2080 Ti Kingpin on LN2. So when I did the Port Royal world record of well over, I mean the 13K barrier score, the 13,000 something, when I tried to run the card with the CPU on LN2 in 3D Mark 11 and Vantage, something happened like in the middle of that bench session. So suddenly the CPU became ridiculously unstable, and when I just stopped and when I tried again, I could still boot, let's say like 6.9 at full pot, but it was always like ridiculously unstable, even at 6.8 and almost at 6.7. So now I can only do like, well, 6.7 at best for multi-core like Cinebench or similar, but it's really like dodgy in terms of functionality. So it sometimes works and most of the time it does not, so it just gets some weird instability issues and so on. So I could only run that like rock steady stable at around like -100 and to like -120, like at 6 gigahertz or 6.2 max. So that's why I used very low clock speed on the 7970 results, because it's pretty much, it doesn't want to go anymore. First, when I talked about it with different guys, we started to think that maybe the solder is bad between the IHS and the die itself, because when I tested it on water, the overall like overclocking wasn't that much different than how good it was at the beginning, but the temperatures were a little bit like higher than what they should be. But I confirmed this by deleting the CPU. So I gave up as I tested the CPU many times. I did many mounts with different thermal pastes. I tested it a few times on the retail Z390 Dark, and I also tried it on the engineering sample version of the Z390 Dark, and it was exactly the same on both boards. I also tried without Inferno backplate, so I wanted to double check that possibility that Inferno is harming my maximum overclock on my CPU, as I'm using a different thermal pad solution on the Inferno now, as the original one that I got with it has damaged a lot, so I cannot use it anymore. So I just used some very high quality ones from Arctic Cooling. So well, now I just wanted to double check that, and when I ran without Inferno backplate, it was exactly the same. So I can pretty much confirm that Inferno backplate does not affect your maximum overclock. So I deleted the CPU, so I used the same deleting tool, Ivy Bridge top piece, and I used thermal crystal conductor node on the CPU die, and I ran it direct die on the dark, and the maximum overclock on water has come down more than 100 megahertz. So previously, when I first got the CPU, it did around 5.4 for Cinebench at around 1.3 volts with the stock IHS and everything, so just normal thermal paste on top of the IHS. And now with liquid metal on the die and direct die, 5.4 needs almost 1.4 volts to pass, when at the beginning I could pass even 5.5 at 1.38 with relatively cool ambient temperature, but that was with the indium solder and stock IHS, non-lapped, etc. So it's very sad, but it's true. So that is the first CPU I have ever managed to degrade. So always for me, the CPUs have always been the same. So they work and overclock the same as always, or they just die altogether. So this is the first moment I see any of my CPUs to degrade the way like this. I'm not sure what is the root cause of that issue. It could be that some of the sub voltages we have to use to get rid of cold bug can be dangerous for the CPUs, but we have to take that risk in order to get the CPUs to full pot and to run them at the highest possible core frequency. But I don't know, maybe it's just my bad luck, but nothing can do. I'm pretty I could say that I have seen enough of Z390 for now, so I really don't want to test any more 8-core Kaby Lake CPUs, because it has been quite annoying. The 8-core CPUs have been much harder to get to full pot compared to the 6-core CPUs like the 8700K or similar, or even the 7700K. So all the 6-core parts that I had went to full pot really easily. They didn't need any like stupid sub voltages to get rid of a bad cold bug. But so far there are some 8-core CPUs that are really weird in terms of behavior on LN2. So also that also means now that as my RO9900K ES is gone, I don't have a good CPU at the moment to run to run proper 3D. So I cannot challenge the top guys in, let's say, FreeMark Vantage or 11 with the 2080 Ti for best possible score because I don't have good enough CPU. Both the Vantage as well as 3D Mark 11 are kind of CPU limited, so you really need a good CPU to get the top score in that. So for 3D Mark 11 you need at least like 6.95 to challenge the top guys, or well, at least 6.9 in 3D Mark 11 physics and throughout the whole test. But yeah, so the good parts about my session were definitely the 7970 testing. So I still have the icon pot on the 7970, so it went really well. 1850 and almost 1870 in terms of core clock. That's absolutely amazing. If I can get rid of the thermal paste cracking, I'm absolutely sure that 1900 MHz core clock will pass in 3D Mark 11. That will be something absolutely amazing. The VRM temperatures were really bad on the Lightning, so the 7970 Lightning has the same VRM solution as on 780 Ti classified. So the VRM is definitely good, but the overall load is so high already that I need to change the cooling solution on the VRM. So what I at least have to do is that I have to improve the heat sinks for the MOSFET. So I will get some third-party ones that I will place on the front side of the card, so I can use the 680 to demo, as it's pretty much the same as 7970. So I will just change the VRM heatsink on the front side of the card on the 7970 Lightning over here. So I will just remove the stock one as well. This is not a good heatsink solution. This is just like an aluminium plate to dissipate some heat from the VRM. And then I will also use another heatsink on the back side of the card. So that should be enough. Those Brazilian guys, back in the days of 290X, they actually used liquid nitrogen to cool the hot VRM of the 290X Lightning. Because 290X is pretty much the same thing as 7970. So 290X is just 7970 with a bigger or larger core. So the overall heat load on the 290X is so high, so they wanted to use LN2 on the VRMs to keep them at a reasonable temperature, because when the VRMs get to a certain point, the whole card will start to throttle as protection method. So you don't want to see that. So that is one thing to do, but it's quite hard to do, as you have to find your own pot solution for the VRMs. It's very hard to pour. So I will just stick to some high quality heat sinks. So that's pretty much it. So the 7970 went great, and also the Xeon L3014. So I got that over 6 GHz, very nice. Next time I will get the GPU Pi as well, but that test takes over half an hour. So it's really hard to do that in a single session. But that will be for the next time. So what will happen next is that we have some new hardware to be released on the 25th of November. So this month I will have a new video coming up at that time. So stay tuned for that. Then I also grabbed some thermal paste as a few guys requested. So Thermalright released the some new thermal paste some time ago. So this is the Thermalright TFX thermal paste. So they released this and the TF8. So the TFX is a little bit better version than the TF8. And why I wanted to test this is that this has really high thermal conductivity rating for any conventional thermal paste. So this has This has 14.3 watts per meter Kelvin as stated thermal conductivity rating on the paper. So that is really high. So it's higher than thermocristal cryonaut. It's a lot higher than GC Extreme. GC Extreme has 8.5. So I just want to see that does the thermal conductivity rating matter anything when it comes to conventional thermal paste. And if it does well, I will also test this thermal paste on LN2. So I will see if this can do like very nicely on the 7970 or the 2080 Ti. So will this crack the same way as cryonaut or KPX? And I will try to test them in a little bit different way. So the overall differences have been so stupidly small when I have tested them on top of the IHS. So I want to get some like larger differences. So I will try them with the 9900K now that it has been deleted. So I will test the pastes on top of the die, so between the die and the water block itself. So that will be coming. And I also I just grabbed, just for fun, the brand new Silver King liquid metal compound from Thermalright as well, as this was quite good price. So I can test how this compares against the thermocrystal conductor now. Is there any difference? 79 watts of thermal conductivity on this one. So we will see if it's any better than the conductor now. But I think the overall difference will be very small, if there's any. So yeah, that's pretty much it. So stay tuned for brand new hardware video that it will be coming next week. That will be interesting. I will see if I can get the DMI sorted for the 7740X, because I want to see that CPU at full pot. But other than that, I will be getting rid of some stuff now. So I will get rid of the 680 Lightning because it wasn't good enough for me. I need to send the Apex pack. I have already found new owner for the 7350K. So yeah, I will keep on trying with the 7970. We are working on the BIOS still with Buildzoid. So when the BIOS is fully ready for the 7970 Lightning, I will post it for all of the guys on HWBot. So if you want to test it yourself, the custom LN2 BIOS is totally free from overcurrent protection, and it also has improved memory timings on the VMEMS around the GPU. So it has a little bit better performance. For example, in the combined test of modern 3D Mark tests like Firestrike Extreme or 3D Mark 11. Of course, the difference is very small, but there is a little gain from the improved timings. So yeah, so that's pretty much it. Thanks for watching this video. Stay tuned for my video next week. And other than that, thanks for watching, and I'll see you next time.